Okay, so if you forget, here are a couple of key points. Okay, if you have one log only, you try to get the log by itself, so then we can do what we've done before, which is switch the form. You guys already actually know how to do that, okay? If you only see one log, you just try to get it alone, switch to exponential, and then go from there. That we've already done. The part that's new is if you have multiple logs, okay? So when we do this, this is where we use the properties. Whenever you see multiple logs, you use the properties that we've been talking about, adding, subtracting, how can we use that to combine, things like that. Okay? All right, so let's try a couple of these. We'll start easy. You'll see they ask you for domain, and that's actually a really important thing to know before you start solving these, because as you saw before, sometimes you'll get an answer that actually doesn't work. Okay, so if you know what the domain is going in, as soon as you get your answers, you're like, oh, this one works, this one doesn't. Okay, so that's the point. Do you guys remember what the key is for the domain? Good. So to find the domain, the inside of the log has to be greater than 0. So that's all we're going to do. Okay? In fact, let's go ahead and do the domain here. What's on the inside? So it's just x is greater than 0. Done. I don't have to move anything or get things alone. X is already alone. That's my domain. Okay? Over here, the domain we'd have to do x squared minus 6x is greater than 0. Right? But we haven't really done these unless we use the calculator. So it's, if you forgot, let's graph that. X squared minus 6x. Yeah, we don't need to put that, but so x squared minus 6x, there it is. We want to know, when is this greater than 0? Do you remember how we do that from the graph? So visually, it's what parts? The parts that are above what? Parts above the x-axis, right. So we're going, this part works because it's above 0. Right now, no. But as soon as I hit this value, now we're good again. Does that make sense? What do you think these values are?
Zeros.
0, and what's this one?
I'm saying zeros.
Well, yes, they are the zeros. And this first one is 0, and the second one is 6. You're right. Okay? And if you don't know why, think about how you factor this. If you actually factored it, it would be x times x minus 6. So you can do it that way and say, oh, well, one of the zeros is 0, and the other one is 6. You could also do the zeros on the calculator, if you forgot, right? Lots of ways that you guys can do this, so no excuse to say, I don't know how to find domain. Okay? It's easy. So how do I write that? How do I say this part of the graph? X is less than 0, or what's the other part? Greater than 6. Very good. Makes sense there? Okay. And you know what? Before we get to these other ones, now that we've done a couple of domains, let's go ahead and actually solve these, okay? So over here, what could I do first, or what should I do first before we start switching forms? So divide by 6. And what's 12 divided by 6? Okay. Now there's nothing else to do to get that log by itself, right? So we switch it up. What's it going to be when we switch to exponential? And we're done. That's x. X equals 4 squared. What's 4 squared? 16. And now we check. Check with the domain. Is 16 greater than 0? So this is my answer. There's no need to worry. Okay? Yes.
For the domain from B, how did you go from x parentheses x minus 6
To this.
yeah.
So I use the graph. Because we knew that here's where x is 0. Here's where x is 6. It's everything to the left of 0 that's greater, and everything to the right of 6. Does that make sense? Okay. Any other clarifications or? Okay. What can we do here then?
We already did it. Oh.
We did the domain, but now let's actually solve. So how do I solve? Okay. Anytime it's quadratic like that, we got to set it equal to 0. So we have 0 equals x squared. And then what's 2 to the 4? So minus 16. Make sense? I hope we all can factor that. If not, I'd be very afraid for your, not for life per se, but life in this class, I'd be a little worried. How do we factor this? Good. So that means x could be negative 2 or, so now let's check with the domain. Is negative 2 less than 0? Great. Is 8 less than 0? It's not less than 0, but then we look over here. It is greater than 6, so we're okay.
Quick question.
Yes.
Where'd you get that 2 up at the top? Why 2?
Which 2?
The 2, 4.
2 to the 4?
Yeah.
We're switching from log to exponential, right? This is the base.
I
That's.
didn't see that. Okay, never mind.
Does that make sense?
Yeah.
Okay. All right, let's look at C. This has no variables, so we don't have to worry about domain here. But what's the domain for this one?
X is greater than 6.
Everybody see where we're getting x is greater than 6. Okay. So now let's start solving here. The goal, when we see multiple logs, is to condense so that we have one log, and then we can switch the form. How do I put these two as one log? What would it be? Multiply. Good. So it's log base 2 of 4 times x minus 6, and then don't forget, what does this 2 do?
It's the exponent.
Very good, of x minus 6. And so there's our one log, and then that's supposed to equal 4. The log is by itself, right? There's nothing else we can do, so let's switch it. What's the base? So 2 to the 4 equals this stuff. 4 times x minus 6 squared. Rather than multiply things out, let's just get x alone. You see, there's only one x literally on our page, so we can get it alone when we see that. What could I do first?
2 to the 4
Is 16, and then I heard divide by 4, so now we get 4 equals x minus 6 squared. We take the square root, almost, plus or minus 2 equals x minus 6. Who are we to judge if they're going to work or not yet? Okay, let's just find out the answers and then we'll check. So according to this, I could have positive 2, and then what do I do here? Add 6. So what's 2 plus 6? 8. And then I'm also going to have negative 2 plus 6, which is 4. Do you guys see where we're getting 8 and 4 from?
Yes.
Okay, is 8 greater than 6?
Yes.
Is 4 greater than 6? So we cross out the 4. X equals 8 is our only solution.
So then you also check when actually plug in the
Yes.
the original.
Yes. If you want to fully check to see if this works, you'd go back and plug everything in. We're kind of half checking it. We're at the very least making sure our answers make sense. We would never say 4 because 4 doesn't make any sense, but 8 does. Okay? All right, any questions on that? Okay. Let's just do a couple of these, and I think we're going to call it a day. Okay. So now we're going to look at equations that have logs on both sides. Okay. Here we focused on we have a log on one side, we have a log on one side, we have a few different logs on one side. Okay. Here we have logs on both sides. Okay. So when we see something like this, I'll remind you what we just did on the previous page. We got to a point where we had a log equal to a log, and then essentially we just dropped and focused on the inside. Does that make sense? So that's one approach. That'll work here and here. Nope, I lied. Here and D. Okay? When you see an extra number floating around, we're going to have to move the logs over to one side first, kind of like what Nicole suggested in the previous page. You move the log to the other side so that then you can combine it and then you switch it. Okay, so those are the two approaches. Okay? So over here, this is log base 9 of x. What's this 2 really doing here? So it's an exponent of x. Good. And that equals log base 9. What's this minus 1? Remember, this is a negative 1 out here really doing. It's the exponent of 81. Right? So what's 81 to the minus 1? 1 over 81. Very good. That's tricky, but I think you guys are getting pretty good at this. Okay? Once we have log base 9 on both sides, we essentially just look at the arguments or the inside, right? So x squared can equal 1 over 81. And now, square root both sides, so x equals plus or minus 1/9. But we forgot to do this. What's the domain here? X has to be greater than 0, so we're going to ignore the negative. Yeah, so this is our only answer, is 1/9. Okay? I'm only going to do one more example, you guys. You guys have done great. I know I'm bombarding you with all this stuff, and it's a lot, but I'd rather be done so you guys have some time to maybe work on your own. Okay, so over here, this is the other scenario where we have a couple of logs on different sides, and we have this number that's kind of just floating around. So we're going to move the logs together on one side. It really doesn't matter which way you go, but since we're going to probably just leave the 5 there, I would move this log to the other side. Does that make sense?
We would just leave the 5 there?
Yeah, leave the 5 there. So log base 3 of x plus 19 plus log base 3, yep, of x plus 1, and now that equals 5. Okay? And now this is just like the problems above, where we condense it to one log, and then we switch the format. Does that make sense?
Yes.
Okay? Oh, by the way, what's the domain here?
X is greater than
And what else needs to also be true? Okay, so if we need to be greater than negative 19 and also greater than negative 1, it's really just this. Because if you think about the graph, here's negative 19, here's negative 1. We're saying that, because look, if you have an answer, it's got to be able to be plugged into both of these, right? You can't just plug it into one and it works there and then not the other. So if we're greater than negative 19, we're going this way, and we're also greater than negative 1. So do you guys see the overlap here? I could not have any numbers that are less than negative 1 because it might work with the first log, but it definitely won't work with this one.
And they have to work for both.
They have to work for both of them. Exactly right. Okay, so we do want to write down both parts of the domain, and then we just have to make the decision. This is the one that makes the most sense. Because if it works for this, it'll work for all. Make sense?
So
Yes.
like, what, if this was the same situation on a test, would we only have to choose one, or could we stay both?
You would have to put the correct yes. Yes. Okay. So now that we've established that, we're going to condense log base 3 of times, good, and that equals 5. Now we have one single log. Good. Okay, now we do have to multiply it all out and set it to 0, right? So 0, and actually what is 3 to the 5th? Is that 243?
Yes.
Okay. So if I FOIL or distribute this out, we're going to get x squared plus 1x and 19x add up to 20x. I'm running out of space. I'm kind of combining steps there. Is that okay? And then 19 and 1 are 19, but we're going to subtract minus 243 to both sides, right? So what's 19 minus 243? Help me out. 224?
Yeah.
Okay. And now maybe you can factor that. But 224 is kind of a large number. It might take you a while to figure out if it factors or not. At this point, you know what I would do?
Just leave it.
No, you don't just leave it, but let's graph.
We just left it. Will we get it right?
No. You'd get some points for, yes. Now we're going to have to modify our window, right? So if I graph right now, we see part of it. Okay, actually, we could probably just use this to figure it out and factor. What does that look like right there? What value is that? Yes, it does look like a parabola. What, is that 8?
Yeah, it looks like it.
Let's double check.
If it's 8, I'm gonna snap. If it's 8, I'm running out.
Sweet. Okay.
Oh my god, I'm running out. Okay.
Okay. So why are we excited about this? Well, because now I don't have to keep using the calculator. I'm going to go ahead and just say, well, if 8 is a 0, remember that x minus 8 has to be the factor?
Yes.
And we could just kind of work backwards. Okay, well, if 8 is a factor, divide these two. What's the other number here? 28. And that has to be plus. And sure enough, they add up to positive 20, right? So our two answers are potentially 8 and negative 28. Which one doesn't work? That's right, because it's not bigger than negative 1. So our only answer here is x equals 8 only. Okay? You guys kind of seeing how this works?
Yeah.
Okay. So tomorrow